Okay, absolute value inequalities. Now, when we were dealing with absolute value equations, we were taking whatever was inside the absolute value and setting it equal to the positive of the 3 or the negative of the 3, whatever that number was on the outside. That was the piece that we changed the sign to. We have that happening with these inequalities as well, but the setup is a little bit more interesting. So if you have a inequality that looks something like this, the absolute value of x or something is going to be less than c. Our setup here is going to be sandwiching that x or whatever's in the absolute value between the negative c and the positive c. All right, so it is going to sandwich it between. Now, if you have a greater than setup, okay, that was a less than. If it's a greater than symbol, then you are going to structure it into two separate pieces. Okay, you're going to say that x is going to be less than the negative c, or x is going to be greater than the positive c. So I wanted to show you graphically the difference here. If you were sandwiching x between negative c and positive c, it would look something like this, right? And we've been looking at some of those compound inequalities a little bit, where we make sure it's sandwiched between. Now, if you start looking at this piece, think about if you're going less than the negative and then greater than the positive, that's going to start looking like this bit where it's shading just the extremes, not between, but more on the outside. You're shading the extremes here. So if you think about the negative c value, no, we want it to be smaller. If you think about the positive c value, no, we want it to be bigger. Okay, so smaller than the negative, bigger than the positive. It's the extremes. Now, the or equal to. If you had a less than or equal to, it's the same idea as the less than, you just attach the or equal to signs. If you had a greater than or equal to, it's the same as the greater than, or the greater than splits, except you attach the or equal to's. Okay, so that's not a real big deal there. I would like to point out that if you are working with this less than startup, you use less than symbols over here. Okay, anytime you're doing that compound, we talked, it's always going to be less than, because your negative c value is in fact less than your positive c value. The greater thans, it's not using greater than in both of these, right? This is looking at the extremes. We want to go smaller than the negative. We want to go bigger than the positive. So memorize these rules. You're not going to be able to set these problems up correctly if you don't have those rules memorized. All right, let's try an example. Number 6. Solve the following, write the answer in interval notation, and graph. So absolute value of x minus 4 is less than 3. So first step was to isolate, but we don't have to, it's already isolated. So then we need to figure out, well, which rule are we following here? There was a less than rule, there's a greater than rule. And this one is following the less than rule, which means we're going to sandwich it between some less than symbols and between a negative 3 and a positive 3. So our rule was this one right over here. And we are going to sandwich our x minus 4 between a negative 3 and a positive 3. And then solve. So this is where we have to, if we're going to get rid of that plus 4, or sorry, the minus 4, we would have to add 4 to all three sides. Right? Make sure you're getting into every bit of that. So we're actually looking at an answer of positive 1, less than x, less than 7. And then they're going to want you to answer an interval notation and graph. And I like to see a graph before I do interval notation, but that's just a personal preference. Okay, my math lab prefers their interval notation first. So parentheses on the 1 and the 7, because our original sign did not have the or equal to, so we didn't have to include it. It means we could use parentheses here. And it looks like an ordered pair, but context clues tell us that that's not an ordered pair. Okay, that is an interval notation. We're not asked to graph that ordered pair. All right, let's try another one. That was a less than problem. What if we, oh, hang on. Before we talk about the greater than version, I did want to show you graphically what's happening with this stuff as well. So if you were to graph just absolute value of x minus 4, though that's all absolute value graphs are going to be V-shaped. So that's this blue graph right here. That is just absolute value of x minus 4. Okay. And now we could also graph the 3, which is going to be this straight, flat red line. So we're graphing a y1 equals, we're graphing a y2 equals, And we want to know where our V is smaller than that 3 line, which would be all this stuff below, right? Where that V is below that red line, that is where it's smaller. So you think, well, it's all of this area right in here. But what are those X values there? Well, this one right here where it starts being smaller is 1. And where it stops being smaller is 7. And that's what we're seeing with our answers too. Okay, so this all translates into the graphing world as well. But I don't think I have any where you actually have to graph it. I just wanted to show you that it's there. It still coincides with all that stuff. Okay, yes, a greater than symbol now. Let's look at how that's going to play out. Oh, we're going to have to isolate first, right? We've got to get rid of the 2 outside that absolute value, and we're going to have to get rid of that minus 5. Do the minus 5 first. Okay, let's add 5 over, and we have 2 times absolute value, and it's going to be greater than or equal to 14. We do need to get rid of that 2 in front of the absolute value as well, so let's divide by 2. So we have absolute value is going to be greater than or equal to 7. Now, we have the absolute value isolated. Now we need to split it apart, look at our rules. Okay, we got to figure out what to do with this absolute value. So because it's the greater than or equal to actually, this is the extremes. We're going to go smaller than the negative, we're going to go bigger than the positive. And we are going to get to use our or equal to symbols in this as well, because it had or equal to begin with. So we're going to take our 5 minus 2x and set it less than or equal to the negative 7. And we'll set it greater than or equal to the positive 7. So again, we're looking for the extreme part of the graph, not sandwiched between the negative 7, 7. We are looking on the extremes. And now we need to solve both of those. So 5 minus 2x, let's add the 5, subtract the 5. And we have our minus 2x. We need to divide by negative 2, but don't forget, if you multiply or divide by that negative, you have to flip that inequality symbol. So that's going to land us with an x is now greater than or equal to 6. Other side's pretty similar. We subtract 5 and we get 2. Divide by negative 2, don't forget to flip your inequality symbol, and you get x is less than or equal to negative 1. Okay, so graphically, we should, again, see them going on the extremes. So let's look at how these play out. We've got the greater than or equal to 6. So it's going to be all this stuff over here to the right of 6, and we're going to put a bracket on that 6 because of the or equal to. With the negative 1, we've got to go smaller. So that's going to be all this stuff back here. And we have a bracket on the negative 1 because of our or equal to. So we do see the extreme parts of this graph, right? We're not sandwiching it between, but we are looking at the extremes. Now, interval notation for this one, it's a doozy, because now you have 2 intervals there, right? You've got this left-hand interval and you've got this right-hand interval. So you're going to have parenthesis, comma, bracket stuff over here, parenthesis, comma, bracket stuff over there on the next one. So you're actually going to be doing 2 interval notations here because you have 2 pieces to that graph. So let's start with this left-hand side. This left-hand piece starts way back there at negative infinity, and it's going to stop when it hits the negative 1, right? So parenthesis with the negative infinity, comma, all the way up to negative 1, and we had a bracket on the negative 1 because of the or equal to, so we're going to use a bracket in our interval notation. Now for this next piece, we are starting it at 6. That's the lowest that piece can go. And then we're going to run it all the way out to infinity. So again, bracket on the 6, all the way out to positive infinity. Will leave us with something like this. Now, in the math world, there is no and symbol. They use what we call a union symbol. And this is like an uppercase U, but without its tail, okay? It stands for a union symbol, and it's math speak for and. So we're saying that this interval is an answer, and anything in this interval is an answer. Okay, you have one of these fancy U's on your math keyboard in my math lab. Okay, so don't use the U on your computer keyboard. You need to use that union symbol from my math lab keyboard. There is also one that faces down, okay, and that's not union, that's something different. That's for a different day. Okay, so make sure you get the one that is U-shaped. Okay, I think that will get that one wrapped up. All right, I'm gonna make another video for these 2 word problems. They're gonna take some time.